we will start with numerical problems. Okay, today we will discuss or analyze the use of Gauss law for asymmetric charge distribution. Asymmetric charge distribution. When the charge distribution, I have already. Let me recall that I've already, discussed to find electric field when you don't know how the charge is distributed, and Gauss law is going to be very useful there. To invoke with that idea and to inculcate certain facts about the Gauss law, how can it be modified, how can you use it with greater wisdom. Let us see some numerical problems so that I would like to make understand better. Wait. My question is a thin non-conducting ring of radius R has a linear charge density. Lambda is nothing but lambda naught cos phi. You see, this is not a symmetric charge distribution. I am giving this function. This defines that charge distribution is asymmetric. We will see. Look at this cos phi. This is a function varying from -1 to +1. So itself, this expression, I am incorporating here cos phi. Make it the function charge density asymmetric, where lambda naught is a constant. Phi is an azimuthal angle. Well, phi is azimuthal angle. Azimuthal angle. Find the magnitude of electric field strength at two positions. I think I'm interested in two positions: at the center of the ring, and on an axis of the ring is a function of distance x from its center, as a function of distance. Say anything that you can say jet, consider the jet axis from its center. Investigate one, also you can investigate the obtained at x is much greater than r. This is your question. solution, okay, we have a non-conducting ring. This is non-conducting ring and this is the center and it has radius r, and the function of charge distribution is given at lambda naught cos phi. And this, in first quadrant it is positive, and fourth quadrant it is positive. So how charge distribution will look like? If I say the first quadrant, second, third, and fourth, so positive charges will be situated like that, and negative will be like that. Okay, but okay, I have made a mistake. But this will not be uniformly distributed. If I consider this angle phi, then you know this. At 90 is going to be 0, then is it going to be negative? It is going to be 0 here. So it is. It has more density nearer to this axis, nearer to the 0 angle. It is very high. You can say lambda naught at 0 degree. Okay, phi 0. So it is more here, and it is a little bit distributed very, not so much dense. Similarly for negative charge distributions. Okay, now I can tell you that for this d phi segment, this is r d phi, and it contains dq angle is nothing but lambda, this function, and r d phi, and electric field in this direction. And you can say by symmetry that electric field be, of course, in this direction resultant, that is d cos phi, because this angle is going to be phi, and this is dE. I'm not interested in finding in the direction, because in this direction we will see we can integrate with the expression d sin phi, and it will of course be vanish. Okay, we will see the integration. Then you can say, okay, it will be 0. But why we have solved so many problems. So along the symmetry, this is line of symmetry, so we will get electric field in this direction. Okay, this is the axis, symmetrical about this charge distribution, and this is negative also. This makes an additional supplement of the electric field along this axis. So negative charge will contribute the electric field in this direction. So we have taken one function d cos phi, say along this axis. So what is the dE? D is, from the Coulomb's law, is nothing but dq by r square cos phi. You can write the d phi, dq 1 by 4 pi epsilon naught r square lambda r d phi by, I have already written a square cos phi. Now lambda, you see this is lambda 1 by 4 pi epsilon naught r square lambda naught cos phi square. This cos phi and this cos phi is going to be square d phi, and r and this is going to be cancelled out. This r and this is going to be cancelled out. So we have left with this expression and just integrate it. So this constant lambda naught 0 to 2 phi. Well, so we have this integration. Okay, now if you say dE sine phi, now you will integrate it, which kind of expression you will get? 4 pi epsilon naught r, maybe like that, sine theta and cos phi, sine phi and 0 to the pi, and this of course is going to be 0. And you know cos square phi, and from 0 to 2 pi, cos square phi, its average value is half. So you can put this cos square phi is half. So we have lambda by 4 pi, no, average value 4 pi epsilon naught r and half into 2 pi. Going to be cancelled out, and this is going to be cancelled out. So we have 4 pi, pi is cancelled out, lambda epsilon naught r. Okay. This is a question of Irodov. After Irodov, I will solve. This is not for. I will solve. Try to solve David J. Griffith. Okay, and this is Dayal. And PhD questions asked in American university, and this will not for IT student. Of course, you can entertain with all this question if you are preparing for IT advanced. Then of course it needs some calculation, nothing else. But when you're going to solve David Griffith, you need a Laplace, many more things like Poisson's equations and Legendre polynomial, divergence and curl. So from onward lecture, IT student cannot skip it. I will tell you that this is not for IT. Okay, so this is a very simple question. Okay. Right. Now with the given similar charge distribution, same ring, but now not at the center. I am now interested in finding the electric field at distance, say z from here, but on the axis. Okay, and this radius was r, I think. This is this is r, this is radius, this is r. I tell you, today I am ill, but I do these things because I entertain it myself. Now I'm alone and I enjoy it in that way. That's why I'm doing this. Some may be benefited. Not for this. I'm not doing for anybody. I'm doing for myself because I'm enjoying doing all these activities. Okay. But after 2 years, I'm gonna start my own institute and free of cost, of course. No, not free of cost, but with little money. Physics and mathematics and for GATE institute, for GATE classes. Now I am in solitary contemplation. Okay, I'm enjoying myself. That's why I'm not doing anything, because I want to understand my mind. It's very important to understand your mind, emotion. So I'm working on this, mind, emotion and soul. Body is different thing, it is biological one. Okay, after 1 year, maybe COVID is over, one is requesting me to teach, but I have my own plan of my life. Maybe I can go for PhD, who knows? But I'm working on all this. So this is very important thing for me. So realization of yourself, you can realize yourself. I think this is the way of wisdom. I think this is just I'm saying to you. Some personal stuff it is. Okay. So this is the things. Again, in the same way you can take D5. Elementary, and this is going to be R. Again here you can lambda net cos phi R d phi. Okay, this is your dq. You can take this, define the plane. You can see the y-axis and this is one x-axis. So plane, the ring is in the plane of x-y axis. Okay, and this is the axis in z direction. This is axis in z direction. Well, so this is point. You can say this. You can define this coordinate. You can see this angle as a phi. Okay, then you can take this point as r cos phi and r sin phi. Then you can apply the Coulomb's law here. So I can write this coordinate x, y. If we consider x by coordinate, then I can write r cos theta. Let me say x so that I can be free to write I, because I enjoy writing there in this direction I. Say y, and y is equal to r sin phi, phi g. And it's nothing but z k into vector k. So you can write dE in vector form 1 by 4 pi epsilon naught dq by r cube and r. Vector r. Well, and this r, of course, is going to 90 degree. You understand this? Is nothing but under root r square plus z square. Okay, now I can define this r, this vector. Okay, this vector r is z unit vector k minus cos theta I, r cos theta I and r sine theta j. This is going to be r, and you know r vector, and we define, what is dq, this one. You can put this, you will get the answer, d, and perform the integration. Okay, then you can find the answer, e. Little bit calculation is here. It's very, very simple calculation. That's why I'm considering it for IT level, because it is no problems. So everybody who is preparing for IT advanced should solve Irodov at least, not SC Burma. You can solve, but Irodov is, I think, good for you. And BM Sharma. DQ, you can see lambda naught cos phi r d phi r cube r square plus z square, distance is fixed, r z is fixed, square 3, and this vector, you write this z vector k minus r cos theta I minus r sin theta j. Okay, so this cos will be multiply this here, here and here, and only cos, when you perform this integration over 0 to 2 pi, 0 to 2 pi, then cos theta sin 2 theta is going to vanish. Okay, so we will have only one expression, this one. So let me take some liberty to solve it with taking minimum step. So sorry for one, because I think you can understand this. So we have you can write, if you hint, cos theta 0 to 2 pi is going to be 0, and sin theta cos theta 0 to 2 pi is going to be 0, just for a hint. So we have left with 1 by 4 pi epsilon naught lambda naught r square minus k. Okay, this is defines the okay, this is I. How can it be? Because it should be in this direction. I have written something wrong. Seems I'm mistaken here, but I don't know where I made a mistake, but it should be in this direction, and but I am getting in I. Okay, and cos square 2 pi is just pi, and r square plus x square 3:2. This is the value. After calculation, we will solve this. Okay, you can decide. You can find out. I have written some wrong coordinate system. Don't know where I have written, but you can simplify it. This is for you. Okay, I have made mistake, but you can find where I have done this. Will be some calculations I have done wrong where I don't know. Now suppose other problems on this asymmetric charge distribution. Now for over the surface, here we have taken ring. Now over the sphere. Okay. The question: suppose the surface charge density over a sphere of radius r depends on polar angle theta as sigma बराबर sigma naught cos theta, where sigma naught is a positive constant. Okay. So that such a charge distribution can be as a result of so that such charge distribution can be result of a small relative shift of two uniformly charged balls where of radius r, which charge two uniformly charged balls. I will elaborate it and discuss the situation. What is saying? Okay, I will go in details. Don't worry. Which charge are equal in magnitude, magnitude and opposite in sign. Okay, well, now resorting to this representation, find the electric field of strength inside the given sphere. Well, this is a question. Okay, we will go through the same pattern using the Gauss law. So, charge is distributed over the sphere. Okay, let me rub this. No. So we have function charge distribution lambda naught cos theta. This is a spherical coordinate. So charge is distributed over the surface of a sphere. This is the surface of the sphere with this expression, and you know what cos theta plays a role. So maximum amount of charge will gather at this point, positive, first, second, third and fourth. Can first, second, third and fourth, you can write also like this. And it goes gradually decreasing, but same charge, same sign, sorry. And here it will the negative charge and maximum charge will gather here, and gradually it will decrease, amount will decrease. You understand this? Because cos theta do this. For 0 degree it is going to be maximum. Now you have to find the electric field at the inner point. In this case, what will we do? Well, so in the question, the hint is available. What it is saying, it is plain of one thing, that it tells you what is the story it's telling you. It is telling you, well, one thing, that you have two charge distribution. One solid sphere, positive charge distribution, another have same radius, negative charge distribution. Okay, what will happen when you overlap this? What is going to be supposed to be happen? It will neutralize. Total charge will be 0. Okay, is it going to happen? Yes, but overlap it, superimpose this charge with this charge. What will happen? Put this here and shift it, the center O1, the center is O2, and it is like this, shift it. Okay, don't worry with this. This is O1 and this is O2, and distance is very small, lambda. Delta, you can say this. This is your question. And you know what will you find? Here it will find you shift this positive charge upward. Positive charge is here and negative charge is here. And inside it has no charge because it will neutralize. Positive and negative charge will neutralize. So similar condition is available here. But with use of this, we have some general expression for electric field inside this charge distribution. This, what is going to be happen? This is epsilon naught. This, and this is negative 4. Okay, so you can use this. Okay, this following expression, you can find the electric field inside this sphere for this charge distribution. But this charge and this charge distribution is very much similar to this one. Okay, what is happening? This is a small shape, just positive charges, and this is very thin. This thickness is going to be very thin, and here is going to be 0. Charge density is going to be 0. Okay, I do some elementary operation. Take a small thickness here, and this is delta, and this will be just this is delta, and this is delta, and this is going to be theta. This angle is like this. I have just shown a clear picture so that you can understand, and this length will be delta cos theta. Of course, it's very easy to understand. And how much amount of charge we expect to be here? dq. How much? And dq is nothing going to be density delta A area and del cos theta, this thickness, and area is the volume. And can we define the charge density? We are being interested in the charge density. This is nothing but dq by dA. So delta naught del cos theta. Look at this expression and this expression. Do you find this similarity? Yes. If I say this constant is lambda naught delta, then this is exactly the same expression. Okay. Well, so electric field inside this, what will happen due to both these spheres? So we can write electric field, net electric field is going to be due to this one. Okay, you can consider at this point and this is going to be P and join like this. So the electric field will be charge density, and charge density into this thickness, okay, delta naught, is your this constant. O2 vector P due to these positive charges, and electric field, so I say E1, now E2 we have minus delta O1, this is O1 P vector. The net electric field will be nothing but 3 epsilon naught O2 P vector minus ON vector, and this is sigma 3 epsilon naught, and this is the thickness. This is a shift, a small shift. We made it. So this is your electric field. And the shift is this constant. Well, you can write this form sigma naught, this constant, by 3 epsilon naught. This is the electric field inside Okay, when you have this asymmetric charge distribution, you can find electric field inside this sphere is sigma naught 3 epsilon naught, and it is going in this direction because the positive charge is like this. This is the direction of the electric field. Now, one more question. 2-point charges Q and minus Q are separated by distance 2L. Now find the flux of the electric field strength vector across a circle of radius r. So this is the question, okay. So this is a very easy question. This is also a question of Irodov, but it's very easy. Suppose we have positive charge here and negative charge here, and distance between two is 2L, and in the middle between these two charges we have a ring of radius r. Then what is the flux passing through this? You can find the resultant electric field at this point, and I'm taking the elementary. There are two methods you can find this. First, just find the solid angle. This surface obtained at this point. Okay, we can solve it. This is L. This is L, and this is angle theta. And then we know what is the solid angle. It's this surface obtained at this point. That is 2 pi 1 minus cos theta. Okay, I will teach you how to make you learn how to find the solid angle. Okay, and what is the solid angle? But let us consider this is the solid angle. If you know this, because you're solving Irodov, you must know this. And you have 2 pi 1 minus cos theta. This is r square plus L square. R b by h under root L square plus L square. What is the flux passing through due to the Q? This charge alone, and this charge also will pass through this direction. It is producing electric field in this direction. Okay, because it is a negative charge, and this is also producing the electric field in this direction. So two flux will be added. Just we can multiply by the 2. If you are able to find the flux due to this charge alone, then just multiply the 2 So then you can find the flux due to the both two charges, because it is producing the electric field in the same direction, and it is also equal distance. Okay, the solid angle will be also equal. You know that when you have a Q charge, then we have a sphere. It forms a solid angle of 4 pi at this point. And the flux is charge enclosed by epsilon naught. So 4 pi solid angle gave this one flux, one do the elementary operation, and this much solid angle. This is the amount of flux. Okay, then Q by epsilon naught, and sorry, 4 pi 2 pi, multiply this by solid angle, 1 minus L into under root L square plus L square, and multiply with 2. Now you have Q which is going to be cancelled out, under root 1 minus L, sorry, not under root here, R square plus R square. So this is the flux. This is the amount of flux crossing through this surface, a ring, I think, it's a ring, due to this configuration, situated at a symmetrical point from this axis, for this point. But okay, then do one more problem. Now one question. Ball of radius R is uniformly charged with volume density rho. Find the flux electric field strength vector across the ball's section formed by plane located at a distance R naught of the ball. Okay, this is the question. Okay, so let me rub it so that I could have enough space for calculation. This is also a question of Irodov. I think we should do Irodov. Everybody should do Irodov. So question is, you have a ball of radius R. This is a ball of radius R, uniformly charged with volume charge density rho. And now we at a particular distance R naught, we take a section this section. We have cut this section and want to know the flux passing through this section. Okay, and this is the R nut. And what kind of section it appears? This is a front view. It would be circular plate. Isn't it? It will be a circular plate. If you see this. And we have, why I'm doing this, because this chapter to support you the principle of Gauss law. So you know at this point R and this distance is x, and like this distance is x, and you can take this area dx R, and what will be its radius? Its radius of the disk. Radius of disk is this under root R square minus this R square. This is minus. The distance is x. What is the electric field here? And direction is this one. And this area vector is this ts, and this is theta, and this will also theta. This is parallel to this, and along this is theta. Now what is electric field here? ER. E is nothing but sigma R by 3 epsilon naught. Now flux E dot ds. Now we have E ds cos theta. Electric field sigma R by 3 epsilon naught. Now ds, you have 2 pi x dx. And cos theta. And what is the value of cos theta? That is PB, this will be base R naught by R d phi. When you integrate this expression, you will find the answer. So we have d phi, right? All the parameter component of this equation is 2 pi x dx R naught by R. Sigma, oh sorry, this is R, this R naught is going to cancel, or sigma R naught, sorry, 3 pi epsilon naught, 3 epsilon naught, 2 pi x dx, and x is varying from 0 to this one, this radius. So we have 2 pi R naught 3 epsilon naught x dx. I think I haven't escaped anything here. Okay, it's alright. Then it's going to be from 0 to R square minus R naught ka whole square, this to this radius. Now, okay, fine, x squared by 2. So we have a 2 is going to be cancelled. So I can write, sorry, density r naught 3 epsilon naught r square minus r naught whole square. This is the amount of flux. Sorry, I have an integration with the flux. Okay, write this. You can understand, okay, why I'm the importance of this integration. You can understand this step. So this is the flux. This is the amount of flux passing through this section. Okay, next classes I will do the more problems. I think which will be important from Irodov. Thank you.